Okay, thank you for being here. So I'm an independent development architect. I'm mostly doing security stuff. When my kids ask what I do at work, I say that I build login buttons. And behind those login buttons, there's usually SAML2, OpenID Connect, or a mix of them, or, well, complicated stuff. But I do like security, and I've always liked security since I started coding more than 30 years ago. So today we are going to look at Owasp top 10 and see how that how ASP.NET Core stands up to those threats. And to be honest, this version of Owasp top 10 I'm basing this talk on is not the latest one. This is kind of a bonus talk where they asked yesterday if there were anyone that had extra talks to fill empty slots in the schedule. So I bring up one, and obviously someone released a new Owasp top 10 version since I created this talk. But still, the ASP.NET Core mechanisms are the same. So let's get started. So why ASP.NET Core? Well, a fool repeats mistakes, smart person learns from their mistakes, and a wise person learns from others' mistakes. So that's why I want to use Owasp top 10, because that's a top list of other people's mistakes, and we can learn from them. So let's see how is ASP.NET Core standing up to the threats in Owasp top 10. The number one on this version of Owasp top 10 is injection. So what is an injection attack? Well, consider web shop, where we do have a possibility to view orders. Site.com/order, ID equals 17. This would typically be used in a SQL query in this way, that the program takes whatever is after that parameter and puts it into the template here and creates a SQL statement that is run on the SQL server. And an injection attack, well, consider if I entered this order number when trying to access the site. It's still a valid order number, but I also added drop table orders. So the program will happily do what it should. It will take this part, put it there, and create this SQL statement. And if this SQL statement is executed to the database or the web shop, I guess the web shop will not be very healthy afterwards. What do you think? No. So let's have a look at how ASP.NET Core handles the risk of injections. It doesn't. Because what is the default database access when using ASP.NET nowadays? It's LINQ, language integrated query. There's no string manipulation anymore. We are simply using a strongly typed representation of the query, and then we have an engine behind, a hardened engine that creates the actual SQL statements that are run. And that hardened engine, of course, uses correct parameterized queries. And this is something I like with ASP.NET Core. They have secure practices. So go with the stream, follow the stream, use the main tools. It will be secure in most ways. Then, of course, there are exceptions. If you, for example, are using Dapper, it's a popular lightweight ORM with .NET. It's fast. It allows you to write your SQL queries directly. Then you, of course, need to be careful to not open up for injection attacks. But on the other hand, I think that the choice of using Dapper is probably something that is not what is a conscious decision, probably. And with that conscious decision, I hope comes awareness of the risks of using SQL strings. So let's move on to broken authentication. This is my favorite. I'm doing authentication and login buttons most of the time. So when we have authentication, when we go to a website and log on, we have something like this. Username, password, we hit the login button. We send that over to the server. The server validates that. And then, since HTTP is stateless, the next time my client sends a request to that server, the server goes like, who are you? And how did you find me? So what mechanism do we typically use to preserve state or represent a session? I have a special prize. What is the technology we are using? Cookie. You want cookies. Of course, we give it a cookie and the server is happy. Now I want you to have that face because you also get cookies. So let's see at an example on how a login method might look like. And this is actually fun because I did create this example some time back and I meant to put in some issues in this. I meant to put in like 2 or 3 issues. I've used this at a number of conferences and now the list is up to 6 different issues people have found in this code. Let me see if you can find a 7th. I don't know if there is a 7th issue here or not. So, okay, what's wrong? This is something I might have written like 25 years ago to the best of my ability. It's wrong. What's wrong with this?
You don't validate the parameters or SK.
SQL injection, right. We have SQL injection here. What do we have more? Yeah, store the username right away in the cookie. So I have no, I really just put current user username. So what if anyone just modifies the cookie? You could set your own cookie and say you're admin. So it's horrible. Yeah, what more? Yeah, there's no kind of lockout or anything. We can just try whatever as many times as possible. No protection against that. What about the password validation? Is this a good way to validate passwords in a database? They should be salted and hashed, right? We're just storing them, obviously, in clear text. So we have a couple of more on my list, still no new. No lockout. Yep. And
Password requirements.
No password requirements. Yeah, that's actually, or this wouldn't be where we would put in password requirements because this is when we log in and validate the password. So it's not the set password method where we set it. There's a simple logic flaw. If you follow the code, consider what would happen if you enter the wrong password. Still logs you in, exactly. There's no return or anything here. It checks if result not has rows, but then it sets the cookie unconditionally at the end. Either way, that was not intentional. And then there's something when doing cookies, an authentication cookie. We should be a bit more careful about our cookie. What should we make sure about cookies? Same site, and also HTTP only. We should be strict about some attributes on the cookies. So this is a brilliant example on how to not write a login method. Yes?
Not sure, but maybe it would be possible to actually load this with the username and password as query parameters. It's not explicit about it.
No, it actually says HTTP post.
Yeah, but at least in some configurations, it actually accepts as query parameters as well. Depends on the configuration of the controller.
Okay, might be. Usually when you set that kind of requirement, HTTP post, it will require a post. But still, yeah, if that's true, it's bad as well. Because
Post it, but not in the body, but as query parameters.
you mean that way? Yeah, okay. That's new. Okay, that's a new thing. You deserve the second package of cookies for that. Here you are. Now I got it. So, yeah, no guard that the username and password really came from the body. that's right. Okay, so, well, what should we do? We shouldn't do this ourselves. We should use built-in components to do like ASP.NET Identity. So let's look at how authentication works in ASP.NET Core. And first look at what ASP.NET, the ASP.NET Core pipeline works. It's the official name is a chain of responsibility pattern. It's one of the original design patterns in the Gang of Four books from 1994. I usually refer to it as a blame game. It means that the first middleware, the static files middleware, get a chance to handle the request. If it doesn't know, it blames the next one, the authentication middleware, and so on. And at the end of the chain, there's also always a hard-coded 404 middleware that just says 404 doesn't exist and returns. So instead of using that crappy login method from the last slide, we should use ASP.NET Identity, which is a built-in library. I can have some opinions about the design, but it's not insecure. ASP.NET Identity would validate the username and password against the storage, whatever, and then set an app cookie. And on the subsequent request, when the subsequent request comes in, the authentication middleware will check, is there a cookie set? Okay, and let's set the user property on the HTTP context. So subsequent, like the middleware in the pipeline, such as the MVC handler or middleware, will be able to just access user. And that will be the logged in session. But there's one drawback with this, and that is whenever I come to a site that looks like this, I said, oh no. Let's bring out the password manager, let's create another password, let's try to remember this. This is not what people accept nowadays. What people expect is that they should use their favorite social network or external login provider, right? Or in a corporate setup, you want single sign-on with your corporate account. And this is where ASP.NET Identity has a really good data model, because they have the idea that one user can have multiple logins. So there is an identity, your user identity in the application that is connected or mapped to a number of login methods, one or more. So back to our chain of responsibility, blame game, and see how this would work. If I, on that login page, would hit sign in with Google, that would trigger a call to the external authentication handler for Google. That will do the redirect out to Google, where Google does their authentication thingy, and then they post or redirects a result back. That is caught by the authentication handler, authentication middleware that routes the incoming response to the Google authentication handler. The Google authentication handler will, in a typical setup, preserve that in something called an external cookie. So we have two different cookie schemes in a typical setup. We do not want to sign the user in to our application with the identity we got from Google directly. We want to preserve that identity we got from Google, and then we want to redirect them to somewhere in our application where we can see, is this a user that is mapped to an existing account, or is it a new user? Do we want to grab some information we got from Google and store it in our database? Kind of thing. That is typically done in an external callback method. And the external callback method calls into ASP.NET Identity to look up this Google identity we just got here. Is that mapped to a user in our system? And if it is, it calls to the app cookie to set that, preserve that user identity for subsequent requests. And on the subsequent request, we simply use the app cookie, and all of these complex things are hidden. one might ask, why do we do all of this? But, well, this gives us an opportunity to show UI while we hang on to the Google identity we got from Google, and we're still trying to figure out if this is linked to something, where we might want to bring the users through a license acceptance screen or anything, a workflow, before actually letting them into our application. A bit complex maybe, but powerful. So more about authentication. Back in the days, we had web apps, and we had browsers, and we used cookies, and everyone was happy. Then we added more powerful JavaScript applications. We are writing entire client applications that are running in the browser nowadays. And those are typically calling a REST API. And if this had been 4 years ago, I would now have started on a long explanation why the JavaScript app should be an OpenID Connect client and why it should use an OAuth 2 bearer token to call the REST API to mitigate CSRF attacks, etc., etc. But it turns out that no, that was a dead end, design-wise. The up-to-date recommendation is to stick to your cookies and use cookies even for JavaScript applications. And in case your JavaScript app needs to call multiple APIs, it should do that through what is called a backend for frontend. So the JavaScript app should just call API endpoints on its own domain, and then that backend can relay to other services. So that's authentication. Any questions on the authentication block? Okay, let's move on to number 3 on the Owasp top 10 list, sensitive data exposure. This is really about how data is stored, and there are a couple of mechanisms in ASP.NET Core to mitigate this. One is in ASP.NET Identity Core. We mentioned that storing the passwords in plain text, as my silly login method did, was wrong. ASP.NET Identity Core use NIST-approved PBKDF2 algorithm, HMAC SHA-256 with 10,000 iterations as default. It's configurable if you want to have more iterations. We do have a required HTTPS attribute to force some controllers to use HTTPS, but I think that is actually already deprecated. Now, would you run anything on plain HTTP anymore? Nope. Just use HTTPS everywhere. Then we have a piece that you've all used if you're .NET developers many times, probably without knowing about it, is the data protector. So the data protector is a wrapper around low-level encryption primitives that is really simple to use. You can take a data protector, take source string hello world, put it through a data protector, you get some gibberish back, and you can then unprotect it and get hello world back. So why is this important? Well, the data protector is accessed, by the way, by using data protection provider is a service that you can inject into get injection from the DI system, and then you need to create a specific data protector with a purpose, and I'll just show you why in the next slide. To use it, dp.protect hello world or unprotect the protected data. And this is the elegance really of the data protector. It's simple to use. Behind this, we have key management, key rotation, proper encryption, proper signing with strong algorithm, correct uses of AES with initialization vectors, all of that is just so simple to get wrong. So I like this abstraction. It's encryption that like it should be. Just hand in something, a simple method. Where is it used? Well, one example is the authentication cookies. It's really a claims identity that is just run through the data protector and put in the cookie. That's what's in the ASP.NET application cookie. And then I mentioned we had to specify a purpose, and why that? Consider if I have both using data protector with the session cookies, and I also have in my application, I have a wizard where I do some really expensive validation of the data in one step, and I want to carry that on in hidden input fields. And the next time I'm using that data, I just want to trust it without having to revalidate. I could use the data protector to do that. So I can run the complex validation when someone enters the data, put the validated data through data protector, and let it be carried on as a hidden input field for the rest of the wizard. Now consider, what if I enter some data in that wizard that is like user Anders role admin, and then I use that to swap with the cookie. So I don't have the encryption key. I cannot create encrypted values, but I could piggyback on the functionality that I can input information in the wizard that is run through the data protector, and then I can take that encrypted data and put it in the cookie. Well, this is why we have purpose. This is because the reason that we need to specify purpose is that we should not be able to take something that was generated by the data protector for one purpose and abuse it for a different purpose. One thing to mention also with data protection is that when we are running in a modern environment which is load balanced, we need to make sure that the data protection keys are handled in a way, if we're on multiple servers, that they share the same data protection keys and app identifiers. Otherwise, they will not be able to recognize cookies. If a cookie is issued by one node in the cluster and the subsequent request is processed by another node in the cluster, they must be matching keys. If you are running on Azure Web Apps just handles this out of the box, but with AWS, for example, there's some configuration you need to do to ensure the data protection works across the nodes in the cluster. Let's move on to number 4, XML External Entities. You remember XML, that's the old version of JSON where we had angle brackets and where we could do all weird kind of stuff with DTDs, etc. So this is an interesting example of where XML is powerful, but a bit too powerful. What this does is to say that this is a dangerous document with a DTD. It actually resolves this to, when it resolves this entity, it will actually call out to somewhere else, and it will do that. At that point, I can return another entity which contains some stuff, and in the end, I could cause just loading an XML document to actually submit the etc post.wd file to the remote attacker. So consider if I just upload or send in a simple XML file to an API, if they have external entity processing enabled, I could actually steal the password database of that system or user database of that system. So what needs to be done when running an ASP.NET Core to protect against these kind of attacks? Well, once more, section is intentionally left blank because these behaviors are disabled by default in ASP.NET Core. Number 5 on the list, broken access control. This is also related to direct object reference, which is another item on the list, Owasp Lisp. So what if I click this link? It probably shows shopping.com/order and then an ID. If I just modify that URL, enter 47, is that link properly protected? not uncommon to see that people are showing that you're just shown the list of your own orders, but they forgot to protect the actual endpoint. And this is an area where I think ASP.NET Core is so much better than previous versions of ASP.NET, because previous versions of ASP.NET, they had the authorize attribute. Anyone has been using that? Yep. And you could also do roles. The problem with this is that if it is a customer that is only allowed to view their own orders, this doesn't help. Authorize with roles was under the assumption that either you're allowed to execute a method with any kind of parameters, or you're not allowed to access the method at all. With ASP.NET Core, we do have more powerful policies that we should use. And why that? Well, because you do define the policy somewhere else. And now we do not have the knowledge that there is a role or claim of type role that has the value admin. We centralize that knowledge to one place in the application. And we can do a lot more things than just evaluate on the role. We can actually run any kind of code there and implement any kind of complex access rules. Policies are really powerful. This is a simple way to just inline define a policy, but there is a more powerful way where we have a policy that represents by requirements. Requirements are objects carrying parameters. And then we have handlers that verifies requirements. In this example, we could have a generic minimum age handler that can validate any age, and the over 18 policy puts in the requirement with a parameter of 18. That looks a bit ridiculous. Let's take a more complex. Read a journal or medical records. We might have multiple requirements to read medical record. One is that in Sweden, at least, there's a rule you need to have a smart card login or strong authentication mechanisms to be able to read medical records. That can be done by a medical handler. We can also put in another requirement to say that you can only read medical records of someone where you have a patient relationship. So a doctor cannot go in and read any medical record for anyone on the hospital. They are just allowed to do that for their own patients. That can be handled by a handler that checks the booking system to see if this doctor has an appointment booked with that patient. It could also be done by a but we can also have another handler that says, is this doctor in the emergency room? If this was someone coming in by ambulance, there's probably not an appointment because people do not plan to go have an accident and go in by ambulance. An advantage here is that the handlers are full-blown services registered with the DI system, so you can access databases, any service, anything. So it's really powerful, but it's also quite complex. So I would say that it's good to know that this story exists and that there is a powerful authorization concept. But if you can stick to the simple inline policies, do that and move on to the more powerful systems when you need it. But there's more to authorization. We're not yet done. They did a lot of improvements. Let's get back to our order here. That we said we couldn't handle that with a simple authorize attribute because we don't know if a customer is allowed to view order 42. Right? We cannot tell that right away. We need to check the order and see if the current user is actually the customer to that particular order, right? That's called resource-based authorization. So I can first load the order object from the database or storage or wherever I have it, and then I can have a policy where I submit the order retrieved from the database. Let's see here, laser pointer. I include the order as a parameter when evaluating the policy. So what does the policy look like? Well, the policy is part of add authorization in the services registration. You would obviously move this to a separate file if you have complex policies, but let's just do it inline here. We add a policy show order. The policy requires searching, and this is my favorite. Require searching means run this expression over here or this method over here and see if it ensure it returns true. That's the escape hatch out of that horrible, or not horrible, but that complex requirement handler thing. You can just require searching. So the policy here, if a user is allowed to show an order, is that if the user is in role employee, or the owner of the order is the current user, then we allow the user to view the order. Resource-based authorization solves one of the problems. Another problem with authorization is the mismatch that sometimes happen. Do you know when you have that edit button visible, you do a lot of changes and then you hit save just to say access denied? That is just awkward UX. To work around that, we can inject the authorization service into views and actually use the same policy, this policy we're using when the order is saved. Exactly the same policy can be used to decide whether to render the edit button or not when doing MVC. And this is something I really like, that we can do it in one place. So to summarize on authorization, we do have the authorized attribute, which is the very basic thing that just requires the user to be logged in. Don't use roles, use policies. And we do have the policy requirement handler set up that is powerful, but often overkill. Resource-based authorization, which I think is a huge improvement, that you can now first load the resource in a control manner. I mean, I've seen all sort of strange things where they mandated, an application mandated that all URLs contains a specific parameter, so they could have a handcrafted attribute that looks at that parameter, and it's just awkward. This is so much more powerful and natural. We have views, the view-based authorization. So finally, a powerful authorization framework. Questions on authorization in ASP.NET Core? Let's go back to where we're using it. It's simply in this method. Is it me that having sound on? No? I thought it was muted. When we do, sorry, I just need to, I thought I had mute. This is just an excerpt. So really here, what you would have is that before you do load it from your normal data store, without doing any validation, you retrieve it from the database or anything, and once you've retrieved it, you call this block of code. So I simply omitted the resource loading.
Okay, so it's not just attributed to
You have to have it in your code, and you're moving the authorization from an attribute and into the actual body of the controller or whatever method does it. So it's an imperative way to call the authorization service. You still have the attribute option if that is enough, which is often the more simple way, but in some cases you need to do some work and then check authorization by calling the authorization service directly. Was there more questions? Oh, okay, let's move on. Skimming through here, and security misconfiguration. This is about adding services, way back when things just added everything that you could potentially need, and you had even to go to the machine.config to see hidden HTTP modules that were all preloaded into any application running on the system. Those were the days. And if one of those had an issue, you had problems, and you might even not be aware that it was in the machine.config. ASP.NET Core takes the another approach. It just does whatever you map into the pipeline. If you're not adding use static files, it won't even serve static files from anywhere on the file system. If you want to use identity, you need to add it. And this opt-in method really guards against security misconfiguration. Number 7 on the list, cross-site scripting. What is it? Consider we have a simple rating form. If I leave a comment 3, does anyone ever leave 3 stars in a rating form? Have you seen that? People leave 1. This is crap, or 5. This is brilliant. They never leave a number 3. But I would do. Works but nothing fancy, because what I do want to put in there here is a script, evil.com/delcookie.js script tag, because I want this review comment to be published on the site for subsequent visitors to the site. And then my hope is that it will actually render the script tag as a tag. And in many, traditionally, to guard against cross-site scripting, there was really a burden on the developer. Remember to always HTML escape all content you put out. If you forgot that in one single place in your application, you could have cross-site scripting vulnerabilities. What about ASP.NET Core? Let's see. Let's just put out a simple script as a string in Razor. What will it do? Well, it will actually display this, because Razor HTML escapes anything by default. If you actually want to put out pre-formatted HTML, you need to tell Razor that this is indeed already an HTML string. Please do not escape it. And it's once more secure by default. If we forget about it, what would happen is that our HTML will be escaped and the tags visible to the user, and that is something you find in the tests or find just when you run it the first time. But if you forgot to HTML escape it where you should have done it, then it can pass through the test. Yep.
So if you want to put out HTML, does .NET have any function towards the sanitize?
If you want, the built-in functionalities is that either you run it through full escape, and then anything will be escaped and put out as is, or that you say that this is pre-formatted HTML string. I want exactly this HTML string to be put out.
So it's up to you to make sure there's no JavaScript in that HTML you're putting out.
Yeah, because you should never really put out HTML that came from user input.
No, you shouldn't, but some people do.
Um,
So I was wondering if there was any support from the .NET framework that
not that I'm aware of. For example, if you allow people to enter HTML that could be published, no, nothing built in that I'm aware of. So let's move to number 8 on the list, insecure deserialization. So what is that? Well, consider there is a class in the .NET framework that is called temp file collection. What temp file collection does, the idea with the temp file collection is that you create a number of temporary files during some operation, and you want automatic cleanup. So when the temp file collection object is destroyed, it deletes all the files it kept track of. That's handy, right? What if I can send in a JSON object that gets deserialized into a temp file collection instance, and I send in that arbitrary file names that I know are critical to a Windows system. Then when that object is destroyed, it would delete those files. And here is something that is actually one way, the only place in this presentation where I have this red box to be careful. And that is, if you ever do, using the JSON serializer, if you ever switch on type name handling all, you are vulnerable. Never ever deserialize untrusted data with allowing it to deserialize into any class. So deserialization, there are still dangers here. And you need to keep track of if it's trusted data or untrusted data when running it through deserialization. But for example, the data protector, if you serialize data and run it through the data protector, when you're unprotected, you can be sure it's your data and it's secure to just deserialize it. And number 9, on this version of Owasp 10, using components with known vulnerabilities. Who would do that? Well, of course we keep track of our components, do we? It was easier way back. Windows Update saved us with the .NET framework. And it's still, if you're running the .NET framework, it's the responsibility of the Windows system administrator to run it. And also if you're relying on the shared .NET Core, or .NET is nowadays named, it's also the system. But if we are packaging and redistributing the .NET libraries with our application, we are responsible for also updating that. But the same with all other components. What about all those NuGet packages? And this is something that I think that now we have tooling. There was a talk previously today that I couldn't attend about the GitHub, how GitHub helps. And GitHub warns you if you have code that references NuGet packages with known vulnerabilities. But still, you need to keep track of that. You need to update them. And this is really, when our ecosystem is expanding with more components, third-party components, you need to have a strategy to monitor all of them to see if there are security vulnerabilities and update and redeploy if that happens. And this is really nothing that ASP.NET Core as a development environment or web framework can help with. Number 10, finally, not finally, I have a bonus. Number 10, insufficient logging monitoring. Well, I think the built-in logging abilities for ASP.NET Core is great. We have an iLogger that can be injected everywhere. We have structured logging, which means that tools like application insights can help us search easier for parameters and known parameters. And there are a lot of good tooling out there. Just use it. That was all on that version of Owasp 10, but there's one more that I think is so important that I want to mention it, and that's cross-site request forgery. Remember the cookies? So, to you who are lucky to have a bunch of cookies for later, I can tell you they are delicious, but I also want to warn you they are bad for your health if you eat too many of them. When we talk about computer cookies or web cookies, they are simple because they are auto-transmitted, but they are bad because they are auto-transmitted. Let me tell you a story about what happened some years ago. This is a 6L modem, ADSL modem. I had one. It was very common. There were a few 100,000, I think, in Sweden distributed by one of the large operators. It had a page where you could just alter DNS settings, and if you entered information there, it would be sent to some action that stored them. So one day, .NET Online forum, I got a request from a security researcher saying, hey, do I know anyone that has one of these modems? And I said, yes, I do. And he said, oh, great. Please, can you go to this link?
Not suspicious at all.
No, not at all suspicious. So okay, well, I did. And I got a page of kittens. The evil kittens. Of course, I checked the browser dev tools. What is it on this? Well, what happened was that there was an iframe, hidden iframe on this page with a hidden form that they mimic the DNS settings and sent that to the static IP address of my modem. And it changed DNS servers. So suddenly I was not using the right DNS servers, I was using DNS servers. All devices on my home network were now using the DNS servers of the attacker. Just by me going to a simple page, viewing some cute kittens. The problem here is cross-site request forgery. So the evil kittens were able to post to the modem, or rather, the modem accepted settings coming from the evil kittens. They shouldn't. To avoid this, anything that accepts posted data should remember to create a token containing a random component, preferably tied to the current users, encrypt and sign it, store that token in a form field, and store the same token in a cookie. And when there is a post back to your system, verify that the tokens are equal, check the signature and decrypt them, and validate it's still the same user signed on. And to do all of that in ASP.NET Core, add validate anti-forgery token. And that is actually that the default in ASP.NET Core is that whenever you're using a form entry, a form with the ASP-something attributes, the form tag helper kicks in, and the form tag helper ensures that the cookie is created if it doesn't exist, and it ensures the hidden form field is generated. So you actually kind of need to opt out of that behavior to not have the request verification hidden input field in form J generated by Razor. And then you add validate anti-forgery token on the methods. Or you can add it as a global filter. Then same-site restrictions on cookies helps a lot, because if your session cookies are with same-site strict, that would have saved us from the evil kittens. On the other hand, I usually think about that we have like 98%, I think, of users now use browsers that are compatible with the modern cookie restrictions and that are following the same site rules. The problem is, who are those 2% that have legacy browsers? Are they security-aware people? Are those typically people that know how to see a phishing mail or something? No. Those 2% running the legacy browsers are typically people that are not that tech-savvy, and they are typically running an older device that is unpatched. So I think that even though we have same site that is a great tool, I still think we should, for a few more years, carry on having anti-forgery validation or protection. This is actually removed from iOS top 10 since a couple of revisions, because it's not seen as a problem in the wild, but that is thanks to what ASP.NET Core and other frameworks do to protect against this. So that was the bonus. To summarize, ASP.NET Core is mostly secure by default. We have the blame game middleware pipeline. That is good to just understand that it exists and how it relates to authentication. That authentication happens as part of the pipeline. And typically, I forgot to mention that static files are served before authentication is checked. So the static files have no protection at all in a standard setup. And authorization with the policies, a brand new, way more flexible and powerful authorization framework. Data protection, that is a key component behind the scenes, and it's something you might need to configure in a hosting environment. Anti-forgery token, cross-site request forgery. Well, it's a built-in protection that is really smart, but you need to enable it and make sure it runs. So that's all I had for ASP.NET Core meets Owasp Top 10, and my views on this is that I think ASP.NET Core has a really great and solid security foundation to tackle the most common scenarios. Any more questions? I can go back to the summary if you wanted to be curious. Yes?
Are there any downsides to the anti-forgery token attribute? Why is it not enabled by default?
There might be cases where it falsely rejects data. Very few, but I've seen people, for example, running very high volume websites and having data that is not sensitive, and they got rejections and they say, we are losing customers over it. There's also scenarios that if you load a form and then, for example, you get signed out when the form is still open, your session expires, that the anti-forgery middleware will reject it, or handler will reject it, because it is tied to the current user. And that is, in many ways, a protection, so that if you hit save, you see I'm logged in as Anders, and I hit save, I should be sure that I'm actually saving the data to my account and not your account. If you somehow have evil kittens that I've watched that somehow used other vulnerabilities to cause my session to get signed out from my account and signed into your account, I don't want my sensitive data to be saved to your account. So there are some occasions where there might be drawbacks, but usually not. Yes?
Is there a way to configure authentication before the static files or for a specific static file?
Yes, absolutely. It's depending on the order. In the startup file where you have this app.use static files, app.use authentication, just put use authentication before static files. Then that will ensure that you know who the user is, but then you also need to configure the static file middleware to have some authorization rules. Because by default, the static file middleware just serves out files to anyone. I'm sure it can be done, but I don't know how.
And as a second bonus point, I would like to point out that you can pretty easily configure course policies in ASP.NET.
Yeah. You can. So there's a lot. Yeah. Any more questions? Okay. I think that's it and that wraps the first day of the conference, and it's over to the final session, the party. Thank you for attending.